Hi there. In this video, we'll create a simple game room with windows, a door, and a staircase, all directly inside Falco Enigne, without any third-party software. We'll use CSG, which is a fast way to build levels from basic shapes. Let's go. A CSG model is a container that combines all our shapes and manages how they interact. It stores all additive and subtractive elements. So you work with the geometry and the model puts everything together under the hood. Let's start with a simple rectangular room. We'll add a floor, a ceiling, and walls. These will all be add brushes. They add volume to our scene. But first, let's add a directional light. Let's rename our cube to floor. Press the E key and shape the cube using its points. We'll create a duplicate of the floor, name it roof, and move it up. Next, we'll duplicate the roof. Turn that object into a wall and create a few more walls. This way, we can build a room using 6 objects, but we can also do it using just 2 objects. Create the first cube as the outer shell. Duplicate it, set its operation to subtract, and scale it down. That's it. Our second room is ready. Now let's cut out openings, a door and windows. For this, we use subtractive brushes. They carve out geometry from anything added previously. Let's adjust the lighting to make it bright inside. We'll create a window frame using Add and cut out the inner part of the opening using Subtract. Create a new object to act as the window. Set it to subtract right away. We can also use other types of objects, like a sphere. Let's add a cone. Put a sphere on top and use a cube and cylinder to subtract the inner part. We can also create a staircase. We can specify the number of steps, width, height and length. Now let's move on to the navigation parameters. Walkable slope angle, the maximum slope angle the agent can walk on. If the angle is exceeded, the agent won't go there. Walkable height, the height the agent can crawl under. If the space is lower than this, it's considered impassable. Walkable climb, the maximum height the agent can climb. Think of it as a step up without jumping. Walkable radius, the buffer around the agent. If a corridor is narrower than this radius, the agent won't fit. Max edge length defines how long edges can be in the nav mesh. The smaller the value, the more accurate the boundaries. Max simplification error controls how much the system is allowed to simplify the nav mesh. Min region area removes very small regions from the nav mesh. This prevents the AI from trying to reach places it shouldn't. Merge region area merges small regions into larger ones to avoid navigation chaos. Cell size. The size of each grid cell horizontally. Smaller means more accurate, but heavier on performance. Cell height. Same as above, but vertically. It controls the accuracy of height differences.